Welcome to this week's research overview. It's on the struggle with rounding and estimation. Now, interestingly, I used rounding first and then estimation. Rounding is a big focus in elementary schools and middle schools, with the lack of understanding of estimation, which is actually the more important idea. We want kids to be really good at estimating, and then there are a number of different problem-solving ideas with estimation versus the rules with rounding. So we're going to talk about some of the errors, some examples that kids have, how it's related to place value, and then how do we better teach rounding and estimation together. And I'll provide a couple different examples here and there as well. One example, if you're thinking about like estimation is that idea of problem solving, just making numbers simpler so you can add them together, you can multiply and just get a better estimate. And where do these things even come in? So like in real life, we think about budgeting. Now, if I'm thinking about budgeting, I'm almost always going to round up in every situation. Now, when I'm measuring something, that's one where you really have to be more accurate and figure out, like, am I rounding up or down? That might be a different situation. But then there's also things like height. We tend to always round height up. When we talk about our weight, we always round down. So there's some situations why we almost always round up, always round down. Of course, if I'm going shopping, I always want to round up so I have enough money. So there's ideas with estimation that we have to really think about first. Then we'll move into rounding. So rounding is just a specific one tool that we can use within estimation. Okay, so the rounding idea, it's really a lack of understanding place values where we have so many different errors. And so what we want to do is be thinking about a number line, and we're thinking from 0 to 10, and we're thinking of the distance. So we're thinking from 0 to 4.9999, so that distance is the same as 5 to 9.9999. Keep going. So we usually have like gray and a black. We'll have an example here for you. And that focus is then finding if you were in the gray area, we're rounding down. If we're in the black area, we're rounding up. What we tend to do is focus on the digits, which is important. And the reason 5 is that critical idea is there's 10 digits. See if you can remember all the 10 digits. Kids usually will say 1 through 9. For getting critical, 0. So 0, 1, 2, 3, 4 are the first 5 digits. 5, 6, 7, 8, 9 are the second 5. So it creates an even there. And that's why 5 to 9 we round up. So those are some really specific ideas there. Now, one of the examples is just thinking about the distance around the Earth. The distance around the Earth is 24,901 miles. Pretty close around the equator. It's a little bit different at the poles. So then, does that make sense if we say, oh, we have this number, should we round to the nearest 10, 100, 1,000, 10,000? What would make more sense then? So then what would I do? What I want to do then is, you can still underline or focus on the thousand, so that's 4,000. But what I want you to think about is, how many thousands, complete thousands are in that number? You might be thinking, just the 4,000. No. There's also 20,000, so there's 24,000 units. So then on the number line, I'm thinking 24,000, and then what is the next 1,000? 25,000. So there I have there's going to be my rounding, and so then what was it? It was 24,900. So now I can look at the 9 and say, and find that, oh, it's closer to 25,000. So that's why I'm going to round it to, that's about 25,000 miles around the Earth. You have other examples like on budgeting, where you might have 3 amounts, $19.97, $10.14, $4.82. So I'm going to round those to $20, $10, and $5, get 35, and now I have a pretty good estimate that I'm going to need $35 to pay for this amount that I just bought. So that's another example. Now, there are a number of misconceptions or mistakes that kids make. So let's give an example of that. So one is if you had 3 and 9800ths. So that 3.98. We want to round it to the nearest tenth. So what happens is, with the rules, is we say underline the tenth, 9/10, and then circle the hundredths, which is 8/800ths. And so because 8 is greater than 5 or more, then what we do is we go from 9/10 and we go, oh, so the next one is 10/10. So we write that as 3.10. That is wrong. So the error then is not really understanding place value again, where we're thinking we went from 9/10 to 10/10. We write it as 0.10, which is incorrect. That's only 1/10. So the better way, again, is going back to thinking that how many complete tenths are in that number? There are 39 tenths. So what's the next tenth larger? 40 tenths. So it's a slightly different way of thinking about it, very correct and useful. So then between 39 tenths and 40 tenths, now we can go to the hundredths and go, oh, that's an 8. So we're going to go to the next larger tenth, which is 40 tenths, which is also written as 4.0. So 4.0 is yes 4, but it's also 40 tenths. Okay, so to recap, really important things to remember them. Let's focus more on estimation. Let's use real life context. Focus on that number line where it shows the distance from 0 to 4.99 and then from 5 to 9.99. You can also think about the digits. So we have an example of that, the first 5 digits, the second 5 digits. And then we're always thinking about how many complete whatever we're rounding to. So if it's tenths, that's important to say how many complete tenths, then find those two numbers on the number line. And as you start doing that, then you're going to remember those rounding rules and be able to use it correctly, and then in all kinds of great estimation ideas, which we do all the time. So if you like this research overview, we'd also like to hear from you. What is your favorite estimation or rounding story? Please tell us. Please like this and share this. In addition, we want to let you know that we just launched a 7-part free course called Math Success Foundations. So if you think you've been missing something about how to really teach math, check out these courses. There's a little quiz at each one, and they will change how you react to teaching mathematics to your kids. What else? Anything else?
I love it.